Majlis mengucapkan ribuan terima kasih kepada Dr. Nopal Hayu Omar atas ceramah yang disampaikan. Diharap para peserta mendapat info yang berguna dari hasil perkongsian itu tadi. Para hadirin yang dihormati sekalian, kita teruskan lagi majlis dengan sesi ceramah yang seterusnya yang akan disampaikan oleh Dr. Marsyita Binti Hanafi.
Dr. Marsyita Hanafi is a senior lecturer in the Department of Computer and Communication Systems Engineering, UPN. She obtained her PhD in Imperial College London, UK in 2012 on face recognition from face signatures. Her areas of interest include precision agriculture, biometrics, image processing, and artificial intelligence. Please welcome Dr. Marsyita with her topic, the role of artificial intelligence in neuroscience and neuroimaging.
Majlis dengan segala hormat yang mempersilakan.
Thank you very much. Can you guys hear me? Okay. So, alright, you guys have already hear about my background bit, you know. Basically, I'm quite new in this area because I just joined with Prof. Priya, supervising her research student. So as you guys know, I'm more interested in precision architecture. Why? Because it does not need ethical approval. Okay, that's the main concern, right? For medical line. All right, so basically, before I proceed, okay, you guys can see that the role of artificial intelligence. Can I know any of you familiar? How many of you familiar with AI, deep learning, and machine learning? Can you raise up your hand? Only two, yeah. All right, okay. So basically, you know, AI is very. If you know AI, it is a very, what we can say, a beautiful method. Why did I say it's beautiful? Nowadays, you guys know about ChatGPT, right? So you guys can ask any question, even in any language. They will answer you correctly. So that's the beauty of AI. Okay, that's why I fall in love with AI when I did my PhD. Okay, I did my PhD basically in 2007, quite long time ago. At that time, basically, AI is just like what we call cosmetic. Now it's compulsory. Okay, so basically, the role. It's not moving. Okay, so I've listed here some of the roles in what AI can do. Basically, the first one is preprocessing. You guys have heard about preprocessing. It's been basically explained quite about this morning. Yeah, but that's the preprocessing done by AI is a bit different by statistical method and other method. Okay, so basically we have the same process. We have smoothing, we have normalization, we have alignment. So AI basically, it can be the method range from statistical analysis, okay, decision making using machine learning, or decision making using deep learning. All right. So smoothing is like the example is the process is to remove noise from the image. So when we are talking about image here, us as engineer, we see it in terms of pixel. You guys know what is pixel, right? Are you guys aware? Yeah, pixel is like, a rectangle component in the image. So if you see that image here, this image here, okay, it looks like not that big, but basically it contains thousands of pixels. So to process the pixel, you can imagine, if you want to process thousands of pixels, then you really need a very powerful machine to do that, right? If not, it will take ages. It will take you a very long time just to process one image. Okay, smoothing is like filtering. Okay, you remove the noise. So nowadays, thanks goodness, they have learning. So you can use CNN, convolutional neural network, to remove the noise. It is a very advanced and very accurate methods, basically. Okay, for normalization is basically you try to adjust the intensity distribution. Intensity here means that the pixel value. So the range of pixel value is from 0 until 255 for one-dimensional, means that for one channel. For one channel, we say it as grayscale. But if you have RGB, because nowadays this is grayscale, I consider it as grayscale. Okay, so you have the pixel value is from 0 until 255. But if it's RGB image, as here, you know, RGB here, color, so you have 3 channels. Okay, for us, we program it to be one channel. Why? Because, you know, you don't need to repeat 3 times. It will be computational expensive. You want to avoid that. If it's computational expensive, then you really need a power machine, and it is very costly. Okay, so and for realignment is basically you want to tackle the problem of blurred or distorted image, which is caused by the moving of camera or moving of subject within the image position, right? Okay, for the second one is BCI, brain computer interface. I think you guys are aware about this. So it's basically AI help to analyze the movement, the signal from the EEG signal, and the information is being interpreted and then control the external device without any physical movement of the subject. Okay, so this is another beauty of AI. And then for segmentation, you can use existing software that have created normally neurologists, medical line, medical doctor, and everything. They just use the available software. But as engineers, we have to create our own function, basically to extract the, you know, to get the region of interest. Region of interest here, maybe you want to find like brains, okay, the brain or just the skull or the gray matters and so on. All right. Okay. Oh, sorry for the BCI here. There are several applications: cursor control, link control, and spelling device. And AI is widely used for disease detection as well and diagnosis. So you can find lots of research papers about this. Okay. For example, Alzheimer detection or Parkinson detection, automatic. I'm talking about automatic detection. Okay, without having the needs of having human expert, means that the machine will do it by itself. Okay. So in order to know which one is suitable, so you need to identify your goal. What is your goal? Are you going to detect? Are you going to identify? Or, you know, are you going to cluster? For some IU, they might, you know, seem same. Okay, but for us, it will be a great difference. For detection, you have, you know, certain method that can only be used to perform detection, and also for recognition. Okay, you cannot use the same method basically for recognition and for detection. Okay, so what are the problems to be solved? Okay, is it a data-driven problem, or is it a task-driven problem, or is it, you know, you want the machine to learn from mistake? So basically, if data-driven problem means that you need to use unsupervised learning model. Okay, if it's a task-driven model, then you need to use supervised learning model. Okay, and for learn from mistake, basically, you need to use reinforcement learning model. So what are the model? So before I go to the model, I would like to introduce to you what is AI, machine learning, and deep learning. Okay, so AI was introduced in 1950s, so very long time ago. So it is any technique, start with fuzzy logic, simple one. They just use, you know, numeric value percentage in terms for you to perform the classification. And then in 1980s, they have introduced machine learning. So for machine learning, is basically it is a subset of AI. So that's why I put it this way. You can see that machine learning is a subset of the AI. Okay, so here machine learning means that the machine able to learn by itself, or it need help from some from us. Okay, the ones that we are the ones that develop the algorithm. Okay, so but it will learn from the experience. All right. So and then for deep learning, it is just introduced recently. Okay, so the algorithm permits software to train itself to perform tasks. Okay, lots of applications have been using deep learning. So, but the drawback of this algorithm, of this method, is that it requires a vast amount of data. Okay, compared to machine learning or AI, basically you can just several hundreds images in order to process it, in order to get the result. But for deep learning, the larger the better. So if you have, sometimes you need millions of data. Okay, sometimes you need more than 50,000. So depends on how well you develop the algorithm. So that is very important. Okay. So I would like to explain about machine learning and deep learning here. So what are the difference between these two? So basically, you have an input image. Both of them can use the same input image. Okay, you don't have to. If the input image is clear, does not have basically distortion, does not have noise, you can just use it directly. Okay, but be careful, for some method, it does not allow you to process RGB image. Okay, it only accepts grayscale image. Okay, only one channel. So for machine learning, basically, the drawback is that you need to perform feature extraction. Okay, it cannot perform feature extraction by itself. Means that you need additional method, AI method or non-AI method, you can use it. Okay, so for AI methods such as trace transform, okay, they are LBP, linear binary pattern, okay, PCA, principal component analysis. These are the AI, these feature extraction method. Okay. So basically, they will extract the important features, and then these features will be fed to the classifier to perform classification, which is what. All right. So from the classification, then we get the result. Okay. And can you imagine that we need about thousands of images just to produce this result? So means that you have a very powerful machine to do that, right? So, okay, and then for the deep learning, the beauty of it is that you don't need to do separate feature extraction, all done in one shot. Okay, feature extraction and classification. All right, the convolutional layer here will perform the feature extraction part. Okay. So basically, deep machine learning. Okay, machine learning, they can be categorized into three categories. So the first one is supervised learning. So you can see here, supervised learning is a task-driven process. So it means that here, in order to train the machine, you need to label the data first. Okay, it needs to be given. The task is according to the label. All right. So basically, label simple. You can use just only binary number, either 1 or 0. Up to you. Okay, that one is up to you. So you are the one that control. So here, for example, the image with the brain, you label it as 1. With the image with brain tumor, you label it as 1, and without the brain tumor, you label it as 0. Okay, so then it will be used to train your classifier. So for training here, you need to train until you get a very high accuracy. Okay, you must proceed the training until the accuracy is more than 90%. If not, the machine, the algorithm is not reliable. Okay, so and then you can also do validation. Here, task of validation, basically, some say that validation, some say as testing, but I prefer to use validation here because after validation, you have testing layer. Okay. So all in the testing layer, the images that were used to test, they are new one and have not been seen by the classifier before. Here, this part to produce, for example, because you have two class because 1 and 0 considered as 2 classes. Okay, so this part is done at the testing. This one done at the training and validation. All right. So for the this one is for unsupervised learning. So unsupervised learning, it is a data-driven. Why is it data-driven? purely based on data and the data is not labeled. Okay, it is quite challenging compared to supervised learning. All right, so because you have no information about the data and you don't have information about the output as well. So, you know, it is quite challenging, but there are several methods that can be used to perform these tasks. All right, so the result is like this. You know, you have several clusters. Okay, and then this one is reinforcement learning. So it's basically based on hit and trial. Okay, it's just like how we teach our children. Okay, if the children do good deeds, then you give him or her rewards. Okay, but if he, you know, basically do bad deed, then you need to punish the children. So same goes to your machine. Okay, so if it gives you a bad result, you need to punish so that it will not do the same mistake. Okay, but for the one when it does a good deed, but then you need to update. Okay, why? Because we want to get a very high accuracy. All right. Manusia ni sentiasa tamak, eh? All right. So for supervised model, so we have several here. Okay. So regression is it's basically a basic model. Okay, there are two types. I characterize it under two types. So basically linear and nonlinear. So here is the linear. Okay, linear regression. Linear regression means that you use linear equation y equal to mx plus c, right? So here basically we predict the regression model. Actually, what it does, it predicts the behavior of one data based on the value of another data. So this is the part you can see here, the dependent variable and the independent variable. Okay, but this one is prone to give you high overfitting, so it is not favorable basically for regression model. All right, so SVM, I think most of you are very familiar with SVM. Okay, SVM is basically, you know, you use a linear line, or we call it as hyperplane, to classify different classes. So here, for example, we have two classes, so class A and class B. So here is the hyperplane. How do you put the hyperplane? It's based on the margin. Okay, margin here, I've labeled it here. So you try to find the one with the widest margin. Okay, that's how you put your hyperplane. All right. So how to find the margin is basically based on the data. Okay, the ones that reach the margin here, this is called as support vectors. That's why we name it as, the algorithm is named as SVM. Okay, support vector machine. It relies on the support vectors. All right. Okay, decision tree. Decision tree is just like tree. The idea is just like, you know, we have a branch, we have a parent node, we have a child node. So the decision is based on the features here. Okay, this one is prone to error as well. So it is not favorable. Okay, and then we have a random forest. Random forest is basically a collection of decision trees. So the final answer or the final result is basically based on the majority voting from the decision tree. All right. So, and then this is the most famously used because CNN is developed based on neural network. All right. So basic neural network, it only has 3 layers. So the first one is input layer, and then you have the neural network layer, hidden layer, sorry, and then you have the output layer. Okay, this is about the supervised model. Okay, for machine learning, yeah. All right, and then for unsupervised model for machine learning as well. So these 3 are famously used: K-mean, PSME, and PCA. So K-mean is basically you assign cluster to the data. You find the one with the similar characteristic, and this is based on the centroid here. What we call is the K value. All right, and then here you have PSME and PCA. They are dimensional reduction algorithm. Means that you have a very large data. Large data here we call it as high dimensional data. Means that you have like thousands of columns. So how you going to analyze? So you to ingest, right? Because too many data. So what you can do is that use these 2 methods to reduce the dimension, to represent it in a much lower dimensional space, right? So for reinforcement learning, model. So this is based on hit and trial. So the three famously used are Monte Carlo tree search, okay, temporal difference learning, and Q-learning. This one is based on the search algorithm, okay. Search algorithm means that it constructs this decision, it constructs tree based on the action, all right. But for this one, it finds the value, okay. Because we are still in machine learning, so as I've told before, that one of the important things in machine learning is to find the right feature extraction method. Okay, why is it important to find the right feature extraction method? If you extract, undistinguished features, the problem is that you will absolutely get a low accuracy. We don't want that to happen. So you need to find a method that can basically extract distinguished features. So these are several methods that can be used, PCA and trace transform. So, and sometimes, okay, when you extract features, you might end up having like 1,000 features. Too many. You cannot fit them all into your classifier. Okay, it will be like, computational expensive. We don't want that to happen. So what you can do is you just select, certain features only. So this is done by feature selection method. Okay, so these are the methods that can be used. You can calculate the correlation, use the correlation, forward selection, and reverse elimination. Okay. And now if it's about the deep learning model. Okay, you guys, if you guys still remember, deep learning, it has its own beauty. It does not, require additional feature extraction method, as it can perform feature extraction by itself. So the most commonly used is CNN. Okay, this one is suitable for classification prediction for two-dimensional data. Two-dimensional data means that image or video. All right, it cannot be used, cannot be applied to one-dimensional like EEG signal. It is just like the signal one-dimensional. We call it as one-dimensional. Okay. If you still want to use it, you need to convert it to spectrogram. You guys know what is spectrogram, right? It has like basically power distribution of the signal, okay, over the time, okay, still in time series. So then you can apply CNN. If not, it cannot be applied. Okay, specially created for two-dimensional data. So here, the features is extracted at the convolutional layer here. Okay. So for the fully connected layer, it will perform the classification. For us engineer, we need to design this. What the student need is that identify how big your convolutional layer and how big is your fully connected layer. So it depends on the data that you use. Okay, the complicated the data, hopefully the algorithm is not complicated. You try to, simplify things because you want to avoid computational expensive, right? So another one is autoencoder. So autoencoder, basically it has encoder and decoder. This is the encoder part and this is the decoder part. All right, it is used basically to model sequence of data. Same goes to R and N. Okay, and then for GAN, what we call it generative adversarial network. Okay, here you construct a new images using GAN. You can construct new images using this algorithm. But here you need to basically use random input vector and then use generator model to create fake image, right? So the fake image will be compared at this model with the real. Okay, and then you get the output. Either it is real or fake. Then it will be continuously updated, right? Until you get the accuracy that you want. Okay. So for data allocation, so basically for deep learning, for machine learning, data allocation is very important. Okay, you need to decide how many data to use for training and how many data to use for testing. You cannot just simply use 50% for training, 50% for testing. It is not validate, okay? And your result will not be acceptable. It will not be publishable. All right. So because the classifier is not trained well with only 50% of the data. Okay, I'm talking about if you have 1,000, only 50% of it, 500, not enough. It will not produce a reliable algorithm. Okay, but here the expected or the common distribution of data is 80-20, 70-30. You can just separate into training set and testing set. Means that for the whole 80% for training and only 20% for testing. But coming back again, some like what I've shown you previously, some researcher, okay, some programmer, they would like to validate the algorithm first. So that is why we have here. All right. So we if this one, it cannot be normally the maximum is just 80%. So if this one is 80%, you can assign here 60. This one is 20, or maybe this one is 70. This one is 10. Okay, but don't exceed 80%. Okay, the 20% must be allocated here. So for the performance, this is very important. Okay, for us to design a machine learning, a deep learning architecture, this is what we want to know. Okay, how good is your algorithm? So it is measured with this metric. Okay, accuracy. Accuracy is basically you have this, the formula. You have learned what is true positive, true negative, right? But for false positive, false negative. But for us, the most important is true positive and true negative. For us means that for us programmer engineer, okay? All right, so here true positive is positive, detected as positive. True negative is negative, detected as negative. But if let's say that you have here 80%, this one is 20%. So it is not a good method. You need to increase to basically your target is to get 100% for full. But it is impossible to get 100%. If someone presented to you saying that, okay, I get 100% for true positive and 100% for true negative, basically it is impossible. I never seen that result before. Okay, maybe something wrong with the algorithm. What we call it as overfitting. All right. So here, very good algorithm, acceptable above 90% for both. 90% for both true positive and true negative. The rest will be, false negative and false positive. All right. Okay. So another performance parameter, we use ROC graph, okay, to show how good is the method as well. Right. So this is what I said before: underfitting and overfitting. You can see classification is for machine learning and also deep learning, but illustration for deep learning, normally we use it as error. So it is, presented as this. We present it as this, yeah. So basically, for underfitting, you can see that, some of the red dot that is still over this region, and the blue dot is here. So it means that the machine is not trained well. So you need to feed the machine with more data. For example, if you have only 1,000 data in your data set, and you get this result, means that you need to collect more data. You have no choice. All right. So that's the only choice that you have. So what we want is this, okay, and we don't want this as well. This means that the machine is overtrained. When it is overtrained, what you get is very low training error, but very high testing error. We don't want, that result. Okay. What we want is this: low training error and low testing error. Okay. So the main challenge faced by AI is, here I listed only 3. So because I think that this is, the challenge for us, the programmers. So data quality. Okay. So noisy, incomplete data. So when you have this type of data, you need to, spare lots of time to do the pre-processing. So basically, we will try to avoid this. Yeah, but we try to maintain a high data quality. Right? If you have no choice, then that's the only data that you have. So you need to perform the pre-processing. All right. Okay. Data availability. Some data, it is not publicly available. Right. So when it is not publicly available, you need to subscribe. So it becomes a problem as well. All right. And then generalizability. This means that your algorithm only works well on your data set, but when you test on other data sets, they perform poorly. Okay. What we want is that your algorithm can work well for all types of data sets. So this is the other challenge that faced by AI. It looks easy, but it is very difficult. That's why ChatGPT, they are trained with million. I think more than million, maybe about billions of data, in order to get very good accuracy, very precise result. You can assign anything to the machine and it works well. All right. And basically, they designed the machine into about no more than 3 years. It just launched last year, right? Okay. So, all right, that's it from me. Thank you very much.